Hey guys, it's me, Play. In this tutorial series, you'll learn how to create a space shooter game similar to Asteroids. Here's what the final game will look like. Without wasting any more time, let's get started. First, I'll show you how to install Unity. If you already have it installed, you can skip ahead. Head over to unity.com/download and download Unity Hub. Run the installer and follow the instructions. Once Unity Hub is launched, sign in with your Unity ID. It will prompt you to install the Unity editor. Just click skip installation for now. You can activate your personal license by clicking the settings icon, then going to the licenses tab. To install an editor, head over to the installs tab and click install editor. Then choose the recommended LTS version and hit install. Now you can choose any additional modules. If you don't already have Visual Studio and would like to use it, select it from the modules list. Once everything's installed, it's time to create our project. Head over to the Projects tab and click New Project. Choose the 2D template, give your project a name, and choose its location. You may also need to choose a cloud organization. If you don't have one, you can create one from your Unity dashboard. Finally, click Create Project. After a while, your empty project should show up in the editor. Let's start by creating our player. In the hierarchy, right-click and select Create Empty. Name it Player. In the inspector, the position of the player might be randomized. Right-click on the transform and select Reset. To give our player a body, right-click on it and create a new triangle sprite. To make the player look more aggressive, I'll scale the player by 0.6 on the x-axis. In the Game tab, you can see what our game currently looks like. Now let's add a collider to our player. Add the Polygon Collider 2D so we can adjust the shape of it to our needs. If you expand the component and expand the point section, you'll find an array of points and their positions. We only need 3 points since our player is a triangle. And to adjust the position of the points, we can click this Edit Collider Geometry button, then simply drag the points around. Once you're satisfied, make sure to toggle the Collider Geometry button off so you don't accidentally change anything. Now we can add the Rigid Body 2D component. This component will allow the physics engine to affect the player object. For now, just minimize it. Finally, we can start adding custom functionality through scripting. Create a new folder called Scripts. Then create a new script called Player Movement. Once Unity recompiles, add the script to our player as a component, and double-click the script to open it up in Visual Studio. In the script, we have 2 methods. The start method, which runs once before update when the script is enabled, and the update method, which runs on every frame. To begin with, we'll need a couple of references. One for our rigid body component, and another for our camera. To assign these references, we can use the serialized field attribute so they appear in the inspector. Back in the inspector, you can see they have appeared. Drag the rigid body to the RB reference, and the main camera to the cam reference. Now we need a float for the movement force. Use the serialized field attribute on this as well so we can change it from the inspector. Now we need a vector 2 for our input and a float for our rotation. We can remove the start method since we won't be needing it. And in the update method, we can first set our input variable. We want to set it to the vector2.up axis multiplied by our vertical input, plus the vector2.right axis multiplied by our horizontal input. Here's a quick visual to explain why we're doing this. Vector2.up is simply a vector pointing up with a magnitude of 1. By multiplying it by our input, we can scale its magnitude by 1 or 0 when pressing the W or S key. Similarly, vector2.right is a vector pointing to the right with a length of 1. Adding these vectors gives us an overall vector which contains the inputs from both dimensions. We can then use this vector as a direction for applying force. If we simply debug.log the input vector and play the game, you can see how it changes as we press WASD. Back in the script, remove the debug.log statement. Now we can apply a force in the direction of our input. We do this in the fixedUpdate method, which should be used for applying forces to rigid bodies as it has the frequency of the physics system. Simply use the rigid body add force method, passing in input.normalized multiplied by our movement force. Normalizing the input vector prevents us from moving faster diagonally. If we press our horizontal and vertical keys at the same time, we get a vector that is longer. Remember, the hypotenuse of a triangle is longer than any of its sides. This is why in some games moving diagonally is faster than moving in one direction. We then scale this vector by the move force. Back in the inspector, you can set move force to something like 10 and play the game. Currently, the player falls down. To fix this, set the gravity scale to 0. Now the player moves around normally, however the movement is slow and slippery. Set the linear drag in the rigid body to something like 3 and the move force to something like 30. Now the movement is much more responsive. Let's make the player point towards the mouse. To do this, we will set the rotation variable we made earlier, then apply that to the rigid body. Create a new method that calculates and returns the rotation. First, we need to get the mouse position. We can do this using the camera screen to world point method, passing in the position of the mouse. This method takes in the screen space position and converts it to world space. We then use this position to create a vector called difference that starts at our player's position and points towards the mouse. To do this, simply subtract the mouse world position by the player's transform position. Finally, we can calculate the angle using some trigonometry. Use the 8tan2 method, passing in the difference vectors y and x components. Convert the angle to degrees using the radian to degree constant. We also need to subtract 90 degrees, otherwise the player will always be looking 90 degrees away from the mouse. Finally, return this angle. You can simplify this code by directly returning the statement above. Back in update, set the rotation variable to the value returned by our getRotation method. Then in fixed update, use the rigid body move rotation method to set the rigid body's rotation. If you play the game, you'll see that the player is now pointing towards our mouse, even if we move the player around. Let's clean up the code a bit. I'll first add the private keyword to the update method for consistency, even though it's implied, and I'll move the opening bracket to the same line. Finally, I'll add some headers to our serialized fields to organize them in the inspector. That's much better. Let's recap. In the update method, we do two things. We set a direction vector based on the user input, and we set the rotation based on the position of the mouse. In fixed update, we apply a force to the rigid body to move it in the direction we calculated, and we also set the rigid body's rotation. And there you have it. We created a player controller that feels nice and responsive. In the next video, we'll start working on enemies and shooting. Thanks for watching. If you found this video helpful, make sure to like, and if you want to see more, subscribe.